Hello children. In the previous lectures I discussed about the questions asked in your examination PT1. From today I am going to start new topics. So today's topic is Kirchhoff's law. So let us discuss about Kirchhoff's law. There are two laws proposed by Kirchhoff. They are related to current and voltage. First law is like this. First law. The algebraic sum of electric current at a junction in a closed loop is 0. Got it? The algebraic sum of electric currents at a junction in a closed loop is 0. This is first law. Just see, this is a wire, this is another wire, this is another wire, and this is another wire. Means there are 4 wires. This is the junction of these 4 wires. A current I1 is coming to the junction, current I2 is coming to the junction, current I3 is going out of the junction, current I4 is also coming to the junction. Suppose current I5 is going away from the junction. So algebraic sum of all these currents is 0. This is first law. That is sigma I is equal to 0. Now you see, sigma I means sum of these currents. There is a convention that incoming current is taken as positive and outgoing current is taken as negative. Reverse of this convention can also be used, that outgoing current will be taken as positive and incoming current will be taken as negative. So this convention is not a universal convention. This convention totally depends upon you. Whatever convention you follow, I suggest you to follow the convention as incoming currents positive and outgoing currents negative. So according to that, you see I1 is incoming current. So I1, I2 is incoming current plus I2, I3 is outgoing current, so minus I3 negative, I4 is incoming current, so this is plus I4, again I5 is outgoing current, so this is minus I5, and sum of these is equal to 0. You can write it as I1 plus I2 plus I4 is equal to I3 plus I5. That is, sum of incoming currents is equal to sum of outgoing currents. No, that is sigma I incoming is equal to sigma I outgoing. Got it? Now, suppose you are taking the reverse convention, then I1 will be negative, I2 will be negative, I3 will be positive, I4 will be negative, and I5 will be positive. Even then, finally you will get I1 plus I2 plus I4 is equal to I3 plus I5. Okay? Do you understand? Okay. So you can take any of the convention as per your wish. Now this law is also called a junction law. This law is also called a current law. Means Kirchhoff's first law is called junction law or current law. This is based on conservation of charge, principle of conservation of charge. You see how total charge coming per second towards a junction is equal to total charge going away from the junction per second. So this law is based on principle of conservation of charge. In objective questions, you can be asked that Kirchhoff's first law is based on which principle? What will be your answer? Your answer will be it is based on principle of conservation of charge. Now second law, let us discuss about second law. Second law. Second law says that in a closed loop, algebraic sum of potential differences across the components in a closed loop or closed circuit is 0. That is, sigma V is equal to 0. Algebraic sum of potential difference, sigma V is equal to 0. You can understand it with the diagram. Suppose here is a resistance R1. Here is a cell with EMF E1 and negligible internal resistance. Here is another resistor, suppose R, and here is a third resistor with resistance R2, third resistor with resistance R2, and a cell of EMF E2. Okay. So you see, this is the cell and this is the positive terminal of the cell. So current will flow in this direction. Suppose this current is I1. Here current will flow in this direction. Suppose this current is I2. And at this junction, two currents I1 and I2 are incoming currents. And there is a one-way path through which I1 and I2 will pass. So this is I1 plus I2. So current distribution is made according to Kirchhoff's first law. Is it clear? Again at this junction, I1 will pass along this direction and I2 will pass along this direction. Now put a name to the circuit as A, B, C, D, F and G. I have not taken E so that you should not confuse, because E is EMF. Okay. So A, B, C, D, F, G and A. This is the closed circuit. Got it? Is there any confusion? No. Now let us apply the second law to one of these closed circuits. You see, there are how many closed circuits? A, B, C, G, A, B, D, F, A, G, C, D, F, G. So there are three closed circuits which can be taken into consideration. I am discussing one by one. So if we take closed circuit A, B, C, G, A in the closed loop, A, B, C, G, A. You see, whenever you write closed loop, you must write the last point as the point with which we start the loop. A, B, C, G and A again. It means it starts from A, it ends at A. Now again there is a convention, and reverse of this convention can also be used. What is the convention? Let us discuss that. One way to use the convention is the current is passing through a component, and every component has some resistance. So potential difference will be there across each and every component connected in the circuit, and potential difference is equal to current into resistance, means V is equal to I into R. So in a loop you can move along the direction of current and you can move opposite to the direction of current. Both the situations can be there. Along the direction of current, opposite to the direction of current. So let us discuss the sign convention of potential difference. First point, the potential difference across a component in the closed loop is taken as positive along the direction of the current and negative opposite to the direction of current. Have you understand? Potential difference across a component is taken as positive along the direction of current and negative opposite to the direction of current. You just see, if you take the loop as A, B, C, G, A, you are going A to B. So you are opposite to the direction of current because current is from B to A, I1. So if you take the loop A, B, C, G, A, potential difference across R1 will be minus I1 R1. But if you take the loop as B, A, G, C, B, means along the direction of current, potential difference I1 R1 will be positive. Got it? So potential difference along the direction of current is positive and potential difference opposite to the direction of current is negative. Reverse can also be used, okay, but I will suggest you to use this convention only. Second convention, potential difference or EMF of a cell is also a potential difference. So potential difference across an electric cell is taken as positive if we get positive terminal first. You can also understand it like the potential difference across an electric cell is taken as positive when we move from positive to negative terminal, and it is taken as negative when we move from negative to positive terminal. You just see, if you take the loop A to B, then B to C, C to G and G to A. So what will you have first? Positive terminal of the cell, means you are going from positive to negative terminal. In that situation, E1 will be taken as positive. If you take the loop like B, A, G, C, B, then BA, you are moving from B to A and you have negative terminal to the positive terminal, means first you face negative terminal. In that situation, E1 is taken as negative. Got it? Means along negative to positive terminal, potential difference is taken as negative, and positive to negative terminal, potential difference is taken as positive. Got it? This is my suggestion to have convention. Other conventions are also there, means there can be many conventions available in different books, and different teachers will also teach you in different ways because there is no universal convention. Okay, and this convention is not to be written in the exam. So it depends upon you that which convention is easy to understand, yeah, is easy to use. So in my view, you have to use this convention that along the direction of current, potential difference positive, opposite to direction of current, potential difference negative, from negative to positive terminal of the cell, potential difference negative, from positive to negative terminal of the cell, potential difference positive. Got it? So now let us explain the loop ABCGA for potential difference. You see, AB means we are going from A to B, means opposite to the direction of current, and potential difference across the component opposite to the direction of current will be negative. So potential difference across R1 will be minus I1 R1 from positive to negative terminal of the cell. So E1 will be positive plus E1. From B to C we are going opposite to the direction of current, but there is no resistance. In general, when resistance sign is not there, means there is a simple conducting wire, we don't have potential difference across the conducting wire. Okay, so there will be no potential difference from B to C. Again from C to G, you see current is from G to C and we are going from C to G, so the potential difference will be negative, minus I1 plus I2 into R, and this is equal to 0. Okay, so this is the first loop ABCGA. Is there any confusion? No. Hope you understand the voltage law. Now let us apply the same rule to the loop ABDFA. In the closed loop, so for ABDFA, how can you understand it? You see, AB from A to B. So you already understand in the closed loop, ABDFA. You see, current minus I1 R1 plus E1. There is no potential difference across BD. From D to F, negative terminal to positive terminal of the cell, so minus E2. Along the direction of current, plus I2 R2. There is no potential difference across FA, so this is equal to 0. Got it? So this is the sum of potential differences across each and every components in the closed loop is 0. Okay, so you learnt 2 Kirchhoff's laws. In the next lecture I will discuss the applications of Kirchhoff's laws. Okay, thank you.